Welcome to Yaka Digital Network. This animation shows a basic mathematical locus. Think of it as a moving point that follows a strict rule. As it travels, it stays at a precise fixed distance, forcing it into a perfect circle. A locus is simply a path governed by a strict geometric rule. Here we see the 4 foundational rules for any geometry exam. Top left, a fixed distance from a point creates a circle. Top right, points equidistant from 2 fixed points create a perpendicular bisector. Bottom left, points equidistant from 2 intersecting lines form an angle bisector. And bottom right, a fixed distance from a single line yields 2 parallel boundaries. Knowing these 4 definitions by memory will only get you so far. The true challenge of the exam lies in executing and combining these paths flawlessly, using nothing but a compass, a ruler, and a pencil. Mastering loci is an exercise in translation. You are reading written constraints and physically drawing out precise geometric boundaries. This diagram maps out our capstone problem, the Scout's Compass Challenge. We have a rectangular plot of land, A, B, C, D, measuring 8 centimeters by 6 centimeters. Our first constraint requires a path equidistant from the intersecting lines AB and BC. Because these lines meet at vertex B, we must construct an angle bisector. Watch as the compass sweeps an arc across both lines, then uses those new intersection points to define the exact middle path. Look closely at those small intersecting marks. Never erase them. Examiners actively look for these specific construction arcs to verify you used a compass, rather than guessing the angle with a protractor. If you erase your working, you lose the marks. The visible physical process is treated with the exact same weight as the final drawn line. This animation shows our second constraint being built, finding all points exactly 4 centimeters from vertex A. The compass measures exactly 4 units on a ruler, anchors at point A, and sweeps a circular boundary through the plot. We need to find region R, defined by 2 rules. It must be closer to AB than BC and less than 4 centimeters from A. Pause the video for 5 seconds. Point to the screen where you think region R is located. Let's check your answer by mapping the boundaries. Closer to line AB than BC means we highlight the entire spatial half-plane that sits on the AB side of our constructed angle bisector. Next, less than 4 centimeters from A requires us to highlight the enclosed area strictly inside the boundary arc we swept from vertex A. Solving compound loci simply means finding the spatial intersection of your individual rules. The area where both constraints apply turns green. We finish by neatly cross-hatching this exact overlap, avoiding our construction marks and labeling it R. This final image shows the exact visual standard for a perfect exam paper. The requested region is clearly shaded, but the raw mechanical workings of the compass are completely preserved and visible beneath it. Here is your checklist for securing full marks. Keep your pencil sharp and your compass tight. Never erase your construction arcs. Lightly map your boundaries before you commit, and apply clear, uniform shading to your final labeled region. By adhering to strict geometric rules, you turn an abstract set of instructions into undeniable proof on the page. Thank you for learning with Yaka Digital Network. Keep practicing, and we'll see you in the next lesson.